Alright, well welcome to Chapter 3, Systems of Equations, and the goal of this lesson is to really figure out what is a system of equations. And to do that, we're going to put this in the form of a problem to hopefully give this some context. So, it says on one day, the Henry Ford Museum in Dearborn admitted 4,400 adults and children. So, I don't know how many adults or how many children, but I know there were 4,400 total people. And I also know the museum took in $57,200. Adults are $14 each, students are $10 each, and the question is how many adults and students were admitted to the museum. Now, I could probably do some different strategies for solving this. I mean, I could guess and check. I could, try some numbers of adults and children and hope I hit on the right combination. But honestly, with 4,400, I'd probably be guessing and checking for a really long time. So, a good strategy when you want to use algebra to solve a problem is figure out what you don't know, and I don't know how many adults or how many students, and since those are two things I don't know, probably a good idea to make a variable for each one. So let's say A is the number of adults that were admitted, and S would be the number of students. Now you can use whatever variables you want, X and Y and whatnot, but I like A and S because it's easy to keep track of what's what. Now, when I go to write an equation for this, I'm actually thinking I might need two equations. And the reason I think that is that the problem is asking or telling me about two different things. The first thing it's telling me about is a quantity. 4,400 adults and children, a number of adults and children, and in fact that's what the problem is asking for initially. But also, the problem talks about money. $57,200, $14 for an adult, $10 for a student. And so what I'm going to try to do is to write an equation that basically deals with each one of those in turn. For example, with the quantity, and this is the easier one, I know that the number of adults plus the number of students gives me a total of 4,400 visitors. So that's my quantity equation. So I'm writing one equation that deals just with the quantity aspect of the problem. Now the other aspect is money. So I'm going to write a second equation dealing with the money. Now it's still going to have the same A and S variable, the same number of adults and the number of students, but in this case I know the total amount of money raised was $57,200. The left side of this equation is a little bit trickier, but remember, adults are $14 and students are $10. So, for example, if I had one adult, it would be $14 of revenue. If I had two adults, it would be 2 times 14 is $28 of revenue, and the same for the students. One student's $10, two students are $20, and so on. So $14 times the number of adult tickets plus $10 times the number of student tickets should give me my final total. And what we've created right here is what's called a system of equations. System of equations. And the idea behind this is really pretty straightforward. We have two or more equations, and we have two or more unknowns. In this case, we have exactly two, but it could be more than that. I don't know the number of adults and the number of students, but I'm able to write two equations that talk about that. One dealing with quantity, one dealing with money. And so our objective is going to be to figure out, well, how do I solve one of these? Because, again, guess and check is probably going to be pretty slow. Now, I will tell you that the solution to this happens to be that we had 3,300 adults and we had 1,100 students. Now again, we don't know how we got there, but let's just verify that this is true for a second. So if it's true, then it should satisfy both equations. So looking at the first equation here, 3,300 adults, again that's what I'm telling you my solution is, plus 1,100 students does in fact get me to, gets me to 4,400. And you can verify that on your own, but it works for that one. This particular A and this particular S satisfy the first equation. But if this is really the solution, the same A and the same S will work for the other equation too. So let's check. We've got $14 for 3,300 adults plus $10 for 1,100 students. And what we'll find, if you do the math with a calculator, you will in fact find that raised $57,200. So we've got one A and one S that make both equations true. And so this right here represents the system to our solution. So in the coming videos, we're going to try to figure out, well, how can we solve that algebraically if we don't know the solution in advance?